This lesson is about simplifying exponents. To write these examples in expanded form, we just figure out what the exponent is attached to and then write the base that many times. Since all of the 4 and the y are in parentheses with the exponent of 3, that means that we have 3 4y's in parentheses, and we'll write it exactly the way we see it. In B, the exponent 2 is connected directly to the a. If there was a number right in front of the a, next to the negative sign, it would technically be a -1. So really, we only have one -1, and then we have 2 a's multiplied together. In example C, we have just 1 2 right here. We have 2 y's, and we have 3 of the quantity x minus 3's. Oops, ran out of room. Next, for the zero exponent property, basically any number to the 0 power always equals 1. So we can say a to the n equals 1. The negative exponent property, if you have a number and it's raised to a negative exponent, what the negative means is that you take the number it's attached to, and if it's on top of a fraction bar, you move it to the bottom and make the exponent positive. Now really that 2 would be over a 1, so you would put a 1 on top, and then you would figure out what 2 to the second power is. So that answer would be 1/4. I'll give you another example with numbers. If I gave you 1/3 to the -2, and the negative exponent was on the bottom, you would take the 3 and the squared and put them on top of the fraction bar instead, make the exponent positive, and it'd be over 1. Then you would just figure out what 3 squared is, and it's 9. So for these examples down here, 2 to the -1 means that that 2 needs to go underneath the fraction bar, and the 1 will become positive. We'll put a 1 on top, and your final answer is 1/2, because 2 to the first is 1/2. With example B, first of all, 5 to the 0 is going to equal 1. We'll multiply it by the 3 is to the negative exponent, so instead of being on top of the fraction bar, we'll put it underneath, and it will become +1, and it'll have a 1 on top. Really, when I see something to the 0 power, you can write 1, but sometimes I just cancel it out. And so your final answer here is 1/3. Example C, everything inside of here is to the 0 power, so that whole thing equals 1. In example D, 10 to the 0 equals 1. 2 to the -3, that negative means that the 2 needs to go underneath the fraction bar, and the exponent will become positive. We'll put a 1 on top, and the final answer is 1 over 2 to the 3rd power, which is 8. Whenever you see product of powers and it's a multiplication problem, you are going to add the exponents of like bases. So if we had 4 to the 3rd times 4 to the 5th, we would add those exponents, and we would get 4 to the 8th. In algebra, a to the n times a to the m equals a to the m plus n. Quotient of powers, that's if you have a division problem. When you have same bases for division problems, you don't add the exponents, you subtract the exponents. So if we had 10 to the 5th on top and 10 to the 3rd on bottom, this would be 10 to the 5 minus 3. You always do the top minus the bottom, and it would be 10 squared, or 100. In algebra, a to the m times a to the n, divided by a to the n equals a to the m minus n. Power to a power, when you have parentheses and an exponent out front, you distribute the exponent, and when you distribute, you multiply. So if I had 3 squared to the third power, you would multiply the 2 and 3, and that would be 3 to the 6th, and then you would calculate that out. So this rule in algebra is a to the m to the n is a to the m times n. Power of a product combines 2 of the rules. So if you have 4 squared times 3 squared all to the 4th power, first you would distribute the 4 to those 2 numbers, and then if your bases were like, you would add them up. So this will be 4 to the 2 times 4 is 8, and times 3 to the 2 times 4 is also 8. Now the bases 4 and 3 aren't the same, so you wouldn't be able to combine those. You would just calculate out those numbers. Power of a quotient is similar. You just distribute the exponent to what's on top and bottom. So if I had 1/2 1 squared over 2 squared to the third, you would distribute the 3 on top and on bottom and multiply. So on top it'd be 1 to the 6th. On the bottom it'd be 2 to the 6th. And then you would figure that out. Let's try some of these examples. First, when I look at A, I'm going to take the big numbers, 2 and -5, and multiply those together, which is -10. Here I have x to the third, here I have x to the first. So all together, when we add the 3 and the 1, that would be x to the 4th. On example B, we have a power to a power rule. So what we'll do is write in the secret exponents a to the first and b to the first, and distribute the 2 to both of those. So we have a squared, b squared. There's a secret 1 on that a, so when we distribute the 3 to both of those exponents, we have a to the third, b to the 6th. Now all we do is go through and add up the exponents on our like bases. So all together, that's 2 a's and 3 a's, so that's a to the 5th. And here we have 2 b's, and here we have 6, so all together, that's 8. Example C starts off the same way. I'm going to first fill in my secret exponents, take the numbers outside the parentheses, and distribute them. So this means that I have -2 in parentheses to the 2nd power. 2 times 1 is 2. I have x to the 2 times 3 is 6. Over here I have x to the 3 times 1 is 3. And y to the 2 times 3 is 6. Now I go through and simplify. First I can simplify what -2 to the 2nd power is. That equals 4. Then I can collect all the x's together. I have 6 and 3, so all together that's 9. And last, I don't have any more y's to put with the 6, so that's the final answer. Again, D starts out the same way. I have parentheses, so I need to distribute the number outside to all of the exponents inside. So this will be a to the 2nd, b to the 2 times 4 is 8, over b to the 2 times 7 is 14. The last step is to clean up anything that needs to be canceled out or combined. There's only the a squared, so those stay exactly where they are. With these b's, we have 8 on top and 14 on bottom. The rule is to subtract the top minus the bottom. So we have b to the 8 minus 14 is negative 6. But we cannot leave that negative exponent in our answer. So we relook at it and say, all right, this a squared can stay just the way it is. That's fine. But the b to the negative 6, it needs to go underneath the fraction bar. It was on top, but now it's going to go on bottom. And that 6 will become positive. So that's your final answer. For scientific notation, anytime you see a positive exponent, it means your number is going to get bigger and you move your decimal to the right. Negative exponents make your number smaller, so you move your exponent to the left. For these examples, all you need to do is divide those numbers. When you do that, you get about 2.18. And then we take care of the exponents. We have both bases 10, so we do the top minus the bottom. So 9 minus negative 3, which is 12. Over here, same thing. Divide those numbers. I believe you get 3.9 times 10 to the, we have bases of 10, so we can do the top exponent minus the bottom exponent. So 11 minus negative 6 is 17.